Hello, this is Team 14, and this is our take on the most beautiful machine. This is the product description slide as was presented by the client team. They requested a spectacular safe, which was intended to keep a book safe within it. They wanted it to be capable of being opened with the push of a button, and that it should stay open unless the user is more than 3 meters away. If the user is away for more than 5 seconds, the door of the safe should close automatically, safely preserving the book kept inside. During the design process, there was only one significant question that needed clarification. The ultrasonic sensors being used in the development of the prototype were not sensitive enough to pick up objects more than 3 meters away. When this concern was presented, the client stated that so long as the safe closed while the person using it was not standing directly in front of it, the design would be considered sufficient and effective.
With the help of the machine descriptions provided by the customer, the team created a needs finding and technical specifications chart. The machine needed to be easily operational with the target value being less than 4 steps. The team quantified the easy-to-build specification by restricting the time taken to build the machine to be less than 3 hours and less than 2 hours as the technical requirement and target value respectively. The major objective of the machine was to serve as a safe. This had 2 technical needs: time taken for it to close the lid and maximum distance from the machine before it closed the lid. The values for these 2 components, 5 seconds and 3 meters, were supplied by the clients. Lastly, the machine needed to be large enough to fit a book. The size specification for the storage capacity was determined to be 22 cm by 14 cm by 7 cm and or bigger. System diagram. This diagram represents the functional flow of the machine. The user interface consists of the Raspberry Pi and the button that the user pushes to open the safe. The storage mechanism refers to the storage capacity in which the user can place the book. The motion sensing and closing mechanisms start operating when the machine detects movements 3 meters away from it. After detecting movement, it closes its lid within 5 seconds to secure the book inside the safe.
Okay, now on to our alternative solutions. As we can see in our first draft, we had a system with an opaque lid and box, with a motor on the inside, an ultrasonic sensor on the front, and a button on the top. Now let's move on to our second sketch, our second idea. So for this one, we had the ultrasonic and the sensor in the front, as like the first sketch, but instead of having the lid open from the top, we had it open from the side, hinging upwards. And also, our motors happen to be on the outside. Now into our third design, which was the design we eventually chose. We had the main structure as shown. It was a little open because we only have so many Legos. With a button on the top, or the bottom left of the top corner, if you understand what I'm saying, with an ultrasonic sensor right next to it. Then we had the motors connected to the outside, which is different than sketch 1. So really, the only thing that made a difference between sketch 1 and sketch 2 was the location of the motors. Now this was chosen because motors on the outside allows for it to open the same amount, but without screwing up any of the space inside. So we can hold more things in sketch 3 versus sketch 1. Okay. Let's move on to our analysis of the alternatives. So as we can see, sketch 3 ended up winning. And it was really close though. The only things that really let sketch 3 win over sketch 2 was the ease of implementation and the optimal location of the ultrasonic sensor.
The code for the prototype mainly implements a while loop so that when the code is running, it will constantly be checking for input given when the button is pressed. Once this happens, the code will run through the action of triggering the motors and thus opening the prototype's door. Afterwards, a timer is started, which continues until one of 2 things happens. The timer reaches a total of 5 seconds, or the ultrasonic sensor value rises above 200, whichever one happens first. The motors will then activate in the reverse direction and close the door. A variable called up is also used to check whether or not the door is open so that the same line of code is not repeated multiple times in succession and continuously open or close the door.
This is the image of the final prototype.
As seen here, the first video demonstrates the initial capabilities of the machine, where it will remain open for a total of 5 seconds after the button is pushed, and then close automatically once the time has passed. The second video shown demonstrates what will happen if the user leaves the vicinity of the machine before the 5 seconds is up. As specified by our clients, it will close automatically if the machine detects there is no longer presence directly in front of it. In both cases, the book inserted is safely stored and cannot be removed unless the prototype is activated once more. As evident in the video shown before, the prototype is able to perform all of the actions or purposes specified by the clients. In both situations, for concept and the physical implementation, a button must be pressed in order for the machine to operate and open up, an average book can be held in the compartment, and the machine closes after 5 seconds. The only differing aspect from the initial description is that the prototype, rather than closing when a person is out of the range of 3 meters, closes after a presence is no longer detected in front of the machine. This is due to the ultrasonic sensor being unable to sense accurately at that range, with the clients being notified and approving of this change in function. Overall, the prototype is able to perform all that was specified and even prevents a favorite book from being stolen.